All right, let's start off with very simple mathematics. I have 3 over 5 minus 4 over 7. Very simple math back to elementary level, and you're asked to simplify this. Well, the first thing we need to do is we need to find a common denominator. We could also use a butterfly method. It's really up to us at this point. I think I'm going to go ahead and I'm going to go times 7 using this old school approach. Now I have a common denominator of 35. I have a left side and a right side, and they're separated by subtraction. 21 subtract 20. Well, 21 subtract 20 is 1. 1 over 35 is my fully simplified answer. Can I have a thumbs up or thumbs down if you're understanding? Okay. Here's my next problem. My next problem is going to be negative, let's go 3x over 5x squared plus 2x with a, let's go with a 4 on top. Okay, what do we do here? So we have two approaches. We have our old school method of finding a common denominator, and then we talk about the butterfly method. And the goal in the last few days is how do you know which method to use? Well, I see they have something in common because I know that 5x squared is the same as 5x x. So when I look at 5xx, only looking at the denominators, and 2x, I can see that they have this x in common. So I'm going to choose to use the old school method of finding a common denominator. And I'm going to start with what is the smallest value that 5 and 2 both divide into, and that is 10. So I'm going to take the denominator and the numerator times 5 on the left-hand side, and I'm going to take it times 2 on the right-hand side. Okay, so now they both have a 10. They both have a single x, but they need two x's, and the left-hand side denominator has a 2x's, the right-hand side needs one more. In the denominator, I have 10xx, which is also known as 10x squared. And then I have a left side and I have a right side. Now on the left side, this can be pretty confusing. This is negative 3 times 2. That's a negative 6 with an x. On the right hand side, I have 4 times 5x, which is 20x. These are like terms and I can combine them. Negative 6x and a positive 20x is a positive 14x. But I am not done. I am not done. So what's the fastest way, knowing that you can use a calculator? Many of you would recognize that 14 and 10 are going to be even numbers. I can divide by 2. Others will take and go 14 divided by 10, hit math, fraction, enter, enter, and it's going to reduce these values. So it's going to reduce down to 7/5. Now for the x's, it's a 1-to-1 thing. So I have 1x in the bottom and 1x on top. And they don't just disappear. Remember, they turn into 1. So this is no longer going to be 14, it's a 7. This is no longer a 10, it's a 5. So 7 times 1 is 7, 5 times 1 is 5, but we also have an x in the bottom. Can I have a thumbs up or a thumbs down if you're understanding? Thumbs up, thumbs down. Okay, I'm going to flip over so we have a little more space to work here. Here's my next one. I'm going to have 2x over x squared minus 3 over x plus 4. So I'm going to rewrite the denominator on the left-hand side as xx. And so these are two x's. Yes, put together they're x squared. And on the right-hand denominator, we have x plus 4. So do they have anything in common? They do not. So what method should we use when they have nothing in common? The butterfly method. Okay, what does the butterfly method look like? I'm going to multiply these first. So I'm going to take 2x times x plus 4. And then I'm going to do this diagonal second. 3 times x squared, and my pen is running out. Now in between them will always be this symbol. Whether it's plus or minus, we're going to look back up to the original problem. In the denominator, we're going to push together x, x, and x plus 4. There's no need for you to distribute out the denominator. No need at all. We do need to do it in the numerator. So I'm going to distribute, and I end up with 2x squared plus 8x. Now be careful, this is not just a 3, it's a negative 3, minus negative 3x squared. Okay, in the numerator, I'm looking for any common denominators. Any common terms. So I can combine these. I'm going to go up above where I have a little more space. A positive 2x squared and a negative 3x squared is a negative 1x squared. All of this looks great, right? And I'd have this denominator come up here. All of this looks great, but I'm still not done. When I look at negative 1x squared and positive 8x, what do they have in common? They have an x. So let's take out an x. And when I take an x out of this numerator, I'm left with negative 1x. Let's make sure that works. Negative 1x squared, great, plus 8, plus 8x. That looks great. Now on the bottom, remember, I had x, x, and x plus 4. Am I done? Am I done? Thumbs up. Am I not done? Thumbs down. thumbs up, you're done. Thumbs down, you're not done. I can still do one thing. What else can I still, and a lot of you want to say eliminate or cancel, but really it's going to be simplify. What can I still simplify? What do they still have? An x. These are going to turn into 1s by simplifying. This is my final answer. And by answer we haven't solved, we simply have simplified the problem. Let's look at one more and then we'll have you go on your way. We have 3 over 8x plus 2 over 4 and x plus 1. How do I know if I'm going to use the old school method or if I'm going to use the butterfly method? Well, I'm looking for one thing they have in common, and this is really close. How could I turn a 4 into an 8? Multiplying by 2. So I'm going to go times 2 and times 2. Now, they both contain an 8. Great. But this has a single x, and this has a group of x plus 1. Those are different. So I need to have a single x on the right-hand side. So single x, single x. Okay, now they both have a single x. Now the right-hand side has an x plus 1, but the left-hand side is missing that. So x plus 1 and x plus 1. Now they have the exact same denominator. They have 8x and x plus 1. Now in the numerator over here, I'm going to multiply these right now. I have 3x plus 3. And over here I'm going to multiply these and I have 4x. Am I done? I'm not done simplifying. I look in the numerator and I go, oh, I can put together a 3x and a 4x. And we are completely done. And you may be saying like, well, can't you just like cancel out an x? Can't I just like go like this? I can't do that. Notice how these are being multiplied? These are not being multiplied. So I can't just say 1 for 1. I cannot do that. So that I can't factor anything else out. I'm in complete simplified mode. Let's do one more problem. Let's go with x squared minus 9. On top, let's do x plus 1. And let's go plus 5 over x plus 3. I'm not going to have you answer. I just want you to raise your hand. When you look at the denominators, if you know what I could do next in the denominator, hands up high. I have one hand, 2, 3, 4. Turn to your partner. What should I do next? X plus 3 or 1x plus 3 and 1x minus 3? Okay. Do they have anything in common? Yes. So what method should I use? Old school. So here we go. X plus 3, awesome. But this is missing an x minus 3. So whatever I attach to the bottom, I must attach to the top. Okay, all of this is great. I have x plus 3 and I have x minus 3. Looks good. Now there's nothing I attached up here, so on the left-hand side in the numerator, I only have x plus 1. On the right-hand side, I'm going to distribute to get 5x minus 15. Okay, what can I combine here? So 1x and 5s is 6x, and 1 and negative 15 is a negative 14. All of this looks great, but I do have to ask myself, is 6 and 14, they're both even, what can I take out of them? What can I divide out? A 2. So 3x minus 7, x plus 3, x minus 3. This is my simplified form.